This A-level maths question could easily be a GCSE question, yet it caught so many students out last summer. In their report after the exams, the examiners said that this question was able to discriminate between those getting the top grades and the rest. In fact, the mix of algebraic indices coupled with a geometric sequence caused problems for many candidates, and often their work lacks structure. In fact, embarrassingly, it was evident that many candidates are not as familiar with the laws of indices as they should be, and are not practiced in the setup of proof questions either. Oh dear, let's make sure it doesn't happen to you this summer. So what's the question say? It says the first three terms of a geometric sequence are given here, where k, that appears here, here and here, is a constant. Using algebra and making your reasoning clear, prove that k equals 5/2 for 3 marks. How do we tackle a question like this? Well, it's a geometric sequence. You should know that the first term we write as the letter a, and then we're multiplying each term by a common ratio, which we might call the letter r. So if you multiply a by r, the second term would be ar. And if you multiply that by r again, you'd get the third term, ar. So if you were to divide ar by a, you would get r. And if you were to divide ar squared by ar, you'd also get r. So this is how we can set it up. We can say that ar divided by a, that would be this divided by this, would give us r. And also ar squared divided by ar, that's what we've got here, ar squared divided by ar, would also give us r. So r equals r. That's how we get this equation. What do we do next? Well, notice that the base numbers, the big numbers, are mixed here. We've got a mixture of 3s and 9s. To use our rules of indices, we need to turn them all into the same base. How can we do that? Well, you should know that there's a connection between 3 and 9. To get 9, well, we do 3 times 3. We do 3 squared. So instead of writing 9, I'm going to write 3 squared in brackets. All of the base numbers are now the same. They're all base 3. Before we go on, we can use a rule to simplify this part. What do we do when the powers are right next door to one another? Well, we multiply them. We do 2 times 7 and 2 times negative 2k. And that will give us, in the power, 14 minus 4k. And it's the same thing here, 14 minus 4k in the power. We can also expand the brackets here to get 2k minus 2. Next, what do we do with the powers when we divide and the base numbers are the same? Well, we can subtract them. So we have this minus, be careful, in brackets we have this, because we're subtracting all of this. The brackets are absolutely essential. It's the same here. We have this minus in brackets. Next, we can expand the brackets and simplify, being careful with the minus minus. Remember, that becomes plus. If we do that, we end up with this. Next, because the base numbers are the same, and we're saying that this equals this, well, it must be that the powers are equal to one another. So that's how I formed this equation. The power on the left must equal the power on the right. Next, we can solve the equation by bringing all the k's onto one side, all the numbers onto the other, divide by 14, and we get the answer here for our final 2 marks. Part B. Hence, find the sum to infinity of the geometric sequence. Well, first of all, let's work out what the first term. Remember, the first term we write as the letter A. That was this term. And we know that k is 5/2. Or even if you couldn't do part A, remember you can still do part B using what they gave you in part A anyway, and still pick up all of those marks in part B, even if you couldn't get all of part A. So if you substitute that in, we end up with A, the first term, is actually 243. What about the common ratio? Well, remember, we can get that by dividing this term by this term, for example. And in part A, you might remember that we simplified that to get this, so we can plug in for k, and we end up with r is 1/3 for our first method mark. Next, we can use the sum to infinity formula. Remember, this sum only works, this formula only works, if r is between -1 and 1. And it is here. This common ratio is 1/3. That is between -1 and 1. So we are allowed to use this formula. So we just substitute in A, that was 243, and the common ratio of 1/3. Do the number crunching and we get this for our final mark.